Good morning. Please note down this example. Determine whether the block shown in figure is in equilibrium. Also find the magnitude and direction of the friction force when theta is equal to 30 degrees and P is equal to 200 Newton. And in the figure, it is shown that the force P is acting horizontally. Mu s, that is coefficient of static friction, is 0.3 and mu k, coefficient of kinetic friction, is 0.2. Yes, how do you check that this block is in equilibrium or not? For that, you have to compare two forces. One is F, the actual force. It is the force required to maintain equilibrium. Force required to maintain equilibrium. And FL is the limiting friction, maximum friction. So if the force required to maintain equilibrium is less than the limiting friction, then you can say that the body is in equilibrium. If the force required to maintain equilibrium is equal to the limiting friction, then you can say that the body is in limiting equilibrium. And if the force required to maintain equilibrium is greater than the maximum friction or limiting friction, then you can say that the body is not in equilibrium. So here, body is in equilibrium, means it is at rest. Limiting equilibrium means it is also at rest, but on the verge of motion. So impending motion, about to move, but not moving. So it is limiting condition of equilibrium. And if F is greater than FL, that means the body is in motion. So it is not in equilibrium. Okay. So let us find out F, that is the force required to maintain equilibrium. So to determine the force required to maintain equilibrium, first you have to assume that the body is in equilibrium. Am I right? Then only you can find out the force required to maintain that condition. That is the equilibrium condition. Suppose if you draw first free body diagram, FBD of the block. What is free body diagram? It is the diagram of the body which is isolated from the system, showing all the forces acting on it. Now we are drawing FBD of the block. So block is to be removed from the system. So block is having contact with the inclined surface. So this inclined surface will offer a normal reaction on the block. So what are the forces acting on the block? Weight of the block, it is given 1000 Newton, will act vertically downwards. Force P acting horizontally on the block, magnitude of P is given 200 Newton, right? And the normal reaction offered by the inclined plane, It is perpendicular to the plane, say NR. So it is making an angle theta. Theta is given 30 degrees. Let us say the body under the system of these forces, the body is moving downwards. Now we have to apply force upwards to maintain equilibrium. Say that is F. Please note here, this F is the force required to maintain equilibrium of the body. That force F is to be compared with the friction force, maximum friction force. Okay. Now, after applying this force F, you can say that the body is in equilibrium. So we can write equations of equilibrium, taking x-axis along the plane, y-axis perpendicular to the plane. So we can resolve this 1000 Newton into two components, perpendicular components. The component adjacent to the angle is cos. So it is 1000 cos 30. And the component along the plane, other perpendicular component, 1000 sin 30. Again, this 200 is making an angle 30 degrees with respect to this x-axis. So resolving this 200 into the xy components, you have this 200 cos 30 and the y component is 200 sin 30. Now writing equations of equilibrium. Say summation Fy is equal to 0 plus NR minus 200 sin 30 minus 1000 cos 30, right, is equal to 0. Okay. So here you will get normal reaction as 966.025. Now writing summation Fx is equal to 0, you have plus F minus 1000 sin 30 plus 200 cos 30 is equal to 0. So solving this equation, you get F as 326.79 Newton. So it is the force required to maintain equilibrium. Now what is the limiting friction or maximum friction? It is given by coefficient of static friction into normal reaction, right, as per Coulomb's law of friction. So coefficient of static friction is 0.3 into normal reaction 966.025. So this is 289.807 Newton. As the force required to maintain equilibrium, that is 326.79, is greater than the limiting friction, block is not in equilibrium. Is it clear? So when you say that the block is not in equilibrium, that means it is moving. So when the body is moving, the magnitude of friction force is given as coefficient of kinetic friction into normal reaction. So this F is the friction force. So coefficient of kinetic friction is 0.2 into 966.025. So this will be 193.205. So this is the magnitude of friction force. And what is the direction? Direction of friction force? Here, this F we are getting positive value, right? 326.79. So whatever we have assumed that the block is moving down, therefore we are applying force upwards and we are getting positive value. That means here the block is moving downwards. Therefore the friction force will act upwards. So the magnitude is 193.205. Acting in upward direction. But along the plane.
Yes, sir.
Yeah. Please note on this. A block of mass 150 kg is resting on a plane inclined at 30 degrees with the horizontal as shown. Determine the range of an external force P to maintain equilibrium. Assume coefficient of static friction as 0.25. Range of an external force P. That means minimum to maximum. So this is the given figure. 150 kg block is kept on an inclined plane making an angle 30 degrees. And you have to find out the minimum and maximum values of P for which the block is in equilibrium. What is the minimum possible value of P? Suppose 0. Say P is equal to 0. The block will tends to slide down the plane. So it will slide down the plane, right? Now you have to apply force P such that the block is on the verge of sliding down. Means the block is impending its motion down the plane. At that instant, whatever the force you are applying, that is the minimum force required to maintain equilibrium. Now you increase the value of P. If you increase the magnitude of force P, then the block will develop the tendency to move up the plane. So you have to increase the magnitude of P in such a way that the block is on the verge of moving up the plane. At that instant, the P is maximum value of P. Are you getting my point? So for minimum value of P, impending motion of block is down the plane. For maximum value of P, impending motion is up the plane. So let us find out minimum force required to maintain equilibrium. For that, first draw FBD of the block. Weight of the block, say W. Normal reaction from
The answer is 42.53.
How much?
42.53 Newton.
No. So it is normal reaction. Applied force.
5.24 Newton.
So we are taking x-axis along the plane, y-axis perpendicular to the plane. For minimum force, block is impending its motion down the plane. So the friction force will act up the plane. So magnitude of friction force is coefficient of static friction into normal reaction. Right?
Excuse me, sir.
Yes.
Sir, 425.24 Newton.
Right. So now resolving this W into two components. We have this as 30. So it is W cos 30, W sin 30. So writing summation Fy is equal to 0, NR is equal to W cos 30. But what is W? 150 into 9.81 cos 30. That is the normal reaction.
Sir, for second, 1074.5 Newton.
Right. So it is 1274.35. Then second equation, writing summation Fx is equal to 0. We have plus P plus 0.25 into normal reaction minus W sin 30 is equal to 0. So P plus 0.25 into 1274.35 minus 150 into 9.81 sin 30 is equal to 0. Solving this, my answer is 417.16. That is the minimum force required to maintain equilibrium. Now, for maximum force, impending motion is up the plane. So here friction force will act down the plane, opposite to the direction of impending motion. So you have normal reaction, same as 1274.35. When you write summation Fx is equal to 0, you have plus P minus 0.25 into normal reaction minus W sin 30. Putting the values of normal reaction NR and W, you will get P as 1054.34 Newton. So what is the range of values of P for which the block is in equilibrium? 417.16 less than or equal to P less than or equal to 1054.34 Newton. This is your answer. This is very tricky question. A block of mass m rests on a frictional plane which makes an angle alpha with the horizontal as shown. If the coefficient of friction between the block and the plane is 0.2, determine the angle alpha for a limiting condition. If nothing is mentioned about coefficient of static friction or kinetic friction, so you have to take it as static friction only. So here the coefficient of static friction is 0.2. So for limiting condition, you can draw FPD. Sorry?
U is equal to tan alpha.
Yes. because right 11.31. When the block is impending its motion down the plane under its own weight, then the angle made by the platform with horizontal is known as angle of repose. Right? So here you can say this alpha is angle of repose. And we know that tan of angle of repose is equal to coefficient of static friction. That is 0.2. So alpha is equal to 11.31. Right? Suppose if they give angle of friction,
So we can use angle of friction is equal to angle of repose.
right? Suppose if they give angle of friction as theta, then tan of angle of friction is also coefficient of static friction. That means angle of repose is equal to angle of friction. Okay. So it is 11.31. Now ladder friction. Determine the distance S to which the 90 kg painter can climb without causing the 4-meter ladder to slip at its lower end A, as shown. The top of the 15 kg ladder has a small roller, and at the ground, coefficient of friction is 0.25. The mass center of the painter is directly above his feet. What is the coefficient of friction at B? Coefficient of friction, static friction at the ground, that is at point A, is given 0.25. So what is the coefficient of static friction at B? Anybody?
0.
It is 0. Why?
Because roller will roll without any resistance.
Right. Because it is said that at the top of 15 kg ladder has a small roller. So when this ladder is tending to slip, so this upper portion, upper end B tends to slide down. So instead of sliding, because of roller, it will roll down. Assuming that there is no friction between the roller and the surface. So here coefficient of static friction is 0. So this is the given figure. First step is FBD, free body diagram of the ladder. So what are the forces acting on the ladder? One is its own weight. It will act at the center of gravity of the ladder. I'm saying W. Second is the painter is climbing the ladder, and you have to find out the distance S at which the ladder tends to slip. That is the limiting condition, means about to slip. So weight of the painter, I will say it is P. The distance from A is S. Now this end A is touching the ground. So the ground will offer a normal reaction, say Na, and B, it is touching the vertical surface, the wall. So the wall will offer a normal reaction perpendicular to the plane, say NB. So when the ladder is about to slip, the end A tends to slide towards left. So the friction force here will act towards right. The magnitude of friction force is coefficient of static friction into normal reaction, right? So at B, there is no friction, hence there is no friction force. Now what is the total length of the ladder? 4 meters. So the position of center of gravity. Two meters. Now remaining it is just geometry. You have this as 60 degrees. So total length is 4 meters. So you can have this opposite side 4 sine 60. We have this as 2 cos 60. I am finding all the perpendicular distances. This will be S cos 60. Now for limiting equilibrium, writing equations of equilibrium. Say summation fx is equal to 0. 0.25 Na minus Nb is equal to 0. So equation 1. Then summation Fy is equal to 0 plus Na minus P minus W is equal to 0. What is P? 90 into 9.81. Weight of the painter is given 90 kg. And the weight of the ladder is 15 kg. So it is 15 into 9.81. So from this you will get Na. Then third equation. It is non-concurrent force system, right? Non-concurrent, non-parallel force system. So we can use the moment equation. So taking moments about point A, the algebraic sum of the moments of all forces about point A must be 0. So moment of Na, 0.25 Na will be 0. Moment of P is clockwise. So it is minus P into perpendicular distance is S cos 60. Then moment of W is also clockwise, minus W into 2 cos 60. Then moment of NB is anti-clockwise, so it is plus NB into perpendicular distance is 4 sine 60. 4 sine 60 is equal to 0. So equation 3. Do the calculations.
So 2.81 meters.
Please check. My answers. Na is 1030. Point 05. And NB.
Sir, NB is 257.51.
Right. 257.51. And the distance is 1.68 meters. So here calculations are important. Basically, there are 3 steps in solving the friction or equilibrium problems. First step is free body diagram. That is very, very important. Second is equations of equilibrium. Third is calculations.
Sir,
Yes,
can you summarize the example again?
this ladder is kept against the horizontal ground and the vertical wall surface. So it is kept at 60 degrees, making an angle, right? And weight of the ladder is 15 kg. Now the painter wants to climb the ladder. So initially it is at rest. Now when he started climbing from end A, the tendency of the ladder to slip increases, right? So when he reaches the point or the position at a distance S from A, the ladder is about to slip. That means it is in limiting condition of equilibrium. Is the end A tends to slip towards left and end B downwards. But end B is provided with roller. So it will roll over the surface. So there is no friction. So here coefficient of friction is 0. And it is given coefficient of static friction at A is 0.25. Right. Now, for a limiting equilibrium, we are drawing free body diagram of the ladder. So while drawing free body diagram, you have to consider 3 types of forces acting on the body. One is externally applied forces. Second is support reactions. Third is self-weight, if any. Here, what are the externally applied forces? Weight of the painter. Weight of the painter is acting at a distance S from A. So it is externally applied force. And what are the support reactions? The ladder is being supported by a horizontal ground surface and a vertical wall surface. So these 2 surfaces will offer normal reactions which are perpendicular to the plane. So NA is vertically upwards, NB is horizontally towards left. That is perpendicular to the wall. And third type is self-weight. Weight is given, weight of the ladder. So we are showing all these forces on the ladder. For equilibrium, we are writing equations of equilibrium now, or conditions of equilibrium. Summation, resolving all forces into X and Y components. So writing summation Fx0, summation Fy0, and a moment equation. You can take moments about any point in the plane. So I'm taking moment about A because I can eliminate moment of 0.25 NA and moment of NA being there passing through A. So solving these 3 equations, we have 3 unknowns we can find. That is NA, NB, and S. Our answer is S. Okay.
Yes, sir. Thank you.
Now try to solve this. Determine the smallest angle theta at which the ladder shown can be placed against the vertical wall and the horizontal floor. Smallest angle theta. The coefficient of friction. Here for horizontal floor it is 0.3 and for vertical wall 0.25. If at all it has to slip, it will slip downwards only, and B tends to slip down and end A tends to slip towards left. So accordingly, you have to show the friction forces opposite to the direction of impending motion. So it is the given figure. Now tell me, what are the forces acting on this ladder? Weight of the ladder is not given. So generally in a statement, if weight is not given, we used to neglect. But here, weight is not given and there is no any other external force acting. Am I right? Then you have to consider that the weight of the ladder as say W. You cannot neglect it. Suppose if you neglect the weight, no other force is acting, then the support reactions will be zero. Then this problem will not exist. Are you getting my point? So let weight of the ladder be W, which is acting at the center of gravity of the ladder. And this horizontal floor will exert a normal reaction Na. Vertical wall will exert a normal reaction Nb. And as the ladder is tending to slip downwards, here the friction force will act upwards, whereas at A, the friction force will act towards right. Okay, these are the forces acting on the ladder. So first draw FBD. So this is the center of gravity. Weight is acting vertically downwards. Total length is 15 meters. Center of gravity is the midpoint. 7.5 meter. Normal reaction Na. Friction force 0.3 Na. Here normal reaction is Nb. Friction force 0.25 Nb. Angle theta. So is the first step. Second step is writing equations of equilibrium.
So 23 degree.
23.
23.2.
Let's check. My answer is not matching with that. Let us see. First, you please check these equations. So summation Fx is equal to 0. .3 Na minus Nb is equal to 0. Summation Fy plus Na minus W plus 0.25 Nb is equal to 0. Now taking moments about point A. You can take moments about any point. So taking moments about point A. Moments of these two forces will be 0. Moment of W is clockwise. So minus W into what is the perpendicular distance? W is vertical. So horizontal distance is perpendicular. 7.5 cos theta. And a moment of 0.25 Nb is anti-clockwise plus 0.25 Nb into, this is vertical force, horizontal distance is perpendicular, 15 cos theta. Moment of Nb is also anti-clockwise plus Nb into, Nb is horizontal. So vertical distance is perpendicular. So this is the opposite side. 15 sin theta. Is equal to 0. So this W gets cancelled. So solving this, you can find out angle theta. So I have got NA 0.93 W, NB 0.28 W, and theta 60.487. If anybody is getting this value 60.487, please let me know.
Sir, I am getting 60.08.
Very good. Okay.